Square waves have been used for years in the development and testing and measurement of amplifiers to test the rise and fall time of a transient. And as you approach towards that perfect square, you're improving the timing and delivery of those transients, and so you're essentially reducing distortion and improving the clarity and transparency of sound.
We'll be testing a speaker cable. Here we have the input to the cable, and the cable goes off the table and spools into a box, and then it comes out and enters this board. First, we have a signal generator that's generating the square wave. We're generating a 10 kilohertz square wave, and this cable feeds the signal to this high bandwidth amplifier. This amplifies the signal, which is then sent out the cable, and then the signal comes back into the board where we can examine it with the oscilloscope. We're using a 100 megahertz Tektronix oscilloscope to look at the signals. All right. I have 4 micro circuits in my hand. Together, these comprise the electric field compensation circuit, which is the core of the Zytron technology. We have specially modified this cable with micro connectors at each end of the cable so that we can demonstrate in real time what the technology does. So we'll be able to actually plug these circuits in and pull them out, and you'll be able to see on the oscilloscope what it actually does to the signal. So we have 2 channels that we're going to look at. We're going to look at the output of the amplifier, the input of the cable. So I'm going to connect the scope probe to the wire. Like that. We'll connect the ground. And then this probe, so you see the yellow trace is the input to the cable. Now I'm going to connect the blue trace to the output of the cable. There we go. So, as you can see, now at the end of the cable, this is what happens to the signal. At the end of the cable, you'll notice that the signal is considerably rolled off on the rise and on the fall of the square wave. And what this indicates is that the cable is either absorbing energy or keeping high frequency energy from being transmitted through the wire. Now, we're going to start to insert the electric field compensation circuit. So I'm going to insert these elements into the cable one at a time. There's 4 of them, and you won't really see the total effect until we've completed the circuit with all 4 of the elements. So I put the first 2 in, and now I'm going to complete the circuit by putting the last 2 elements in. And you'll notice that the blue trace is starting to change. And when you look at the scope, you can see that the signal at the output of the cable now more closely resembles the signal that we fed in to the input of the cable. So just to make that clear, I'm going to pull these 2 elements out, which will disable the circuit, so you can clearly see the blue trace, what it's like without the Zytron technology. Here we go.
If you were able to effect that level of difference as an amplifier manufacturer, you would have done something truly significant.
We have the patent application which people can look at, and they can see the specifics of what we're doing. Essentially what we're doing, it's a little complex, but essentially what we're doing is we're splitting the magnetic wave and the electric wave, and we're sending the magnetic wave and the electric wave independently down the wire. So once you make a paradigm shift in technology, then the little things that you used to do to refine a product become almost insignificant. I like to use the analogy of a World War I biplane. You can change the structural components of the plane. You can change the pitch of the prop. You could put a more powerful piston engine in it, and it makes a difference. And the analogy is, in the cable industry, you can change the stranding of the wire, you can change the number of nines of the copper, you can change the insulation materials, you can change the geometry, and it does make a difference. However, once we developed Zytron technology, we now have the equivalent of a jet aircraft compared to a biplane for the old technology.